Hello everyone, welcome back. I'm actually a bit frustrated. I recorded the whole lesson only to find out that I didn't record correctly. So now I have to record it again. I don't want to start over, so I'm gonna just talk a little bit about it and then I'll redo the examples on two separate videos. But at least for the theorem, I'm gonna keep it the same. Now recall that the last lecture we covered, we spoke about the extreme value theorem, which tells us that if you're given a continuous function on a closed interval, then the function given must have both a maximum and a minimum on that interval. So for example, if somebody gives you a function like this, call it f, we can see that f achieves its minimum right down here, and then assuming that these two points are at the same height, then f achieves its maximum at both of these points, and that's okay. It's okay to achieve your maximum at on two different sides of the graph. Now what Rolle's theorem says is that if f is given to be a continuous function on a closed interval ab and differentiable on the open interval ab, then if f is given in this way, if the endpoints, when you evaluate them on the function f of a is equal to the other endpoint f of b, then we are guaranteed to have at least one real number c on the open interval ab, such that the derivative when you evaluate it at c is equal to 0. So for example, if you're given the blue function right here, the blue line, on the closed interval AB, we know that this function is continuous because it's a smooth curve. There are no breaks in it. Because it is a smooth curve, we know that it's differentiable everywhere. And because it is both continuous and differentiable, we just have to check one more factor to see if Rolle's theorem applies, and that is whether f of a is equal to f of b. Well, the way that I drew it, f of a is equal to f of b, which means that we can actually apply Rolle's theorem. Rolle's theorem says that if all these three things are met, then there is a value of x, we call it c just to differentiate it, such that when you take the function and you plug in c, you get that the derivative is equal to 0. Now remember that the derivative gave us the slope of the tangent line. And the tangent line is written in the form of y equals mx plus b. Well, if you have a slope 0, that means that m is 0. So you have 0 times x plus b, which just simply means that y is equal to b. And here b is a number. If you remember from college algebra and pre-calc, whenever you have y equals a constant, then that represents the equation of a horizontal line. So what Rolle's theorem tells us is that when you apply it, the tangent line at c will be a horizontal line. Okay, so let me take it back a little bit. Just to go back over it again. Again, the theorem says that if f is given to be continuous on a closed interval and differentiable on the open interval, and if the endpoints are equal, then we are guaranteed to have a value between the endpoints, between a and b, such that the derivative, when you evaluate it at this point that's between a and b, is going to be equal to 0. Okay, on the next two videos, on the next two videos, I'll cover some examples of this. Thank you for your time.